square root negative x plus 3. And we'll say that that is good from -6 less than x less than or equal to 9. And we'll go, sorry, that's completely wrong. -1. And then we'll go -4x plus 1 for -1 less than x less than 2. And then we'll go x squared we'll go x minus 3 squared minus 5 for x greater than or equal to 2. Okay, I think this will work. So what did we do first yesterday with these types of problems?
I think we put, well, basically the numbers on the right into a, what's it called?
Table.
Yeah, table,
Some
sorry.
sort of a table, T-chart, whatever. Okay, so do that for me for the first one and let me know what you come up with.
Okay. So, okay. So is it just numbers that are in between -6 and -1?
No, you want to use the endpoints if you
Oh,
can.
right, right. Yeah, we did this.
That's typically the best way to
Right.
proceed.
Okay.
You could pick points, but there's only certain ones that work nicely.
Yeah. All right. Okay, so -6, -6.
Okay.
And then -1, -1, -4.
All right. Is it an open or a closed circle, each of those?
Uh, the first one is open, the second one is closed.
All right, very good. So make me a T-chart for the next one, please.
Okay. The first x is -1 and the second x is 2.
Okay.
The first y is 5. And then -7 is the
All right,
second
good.
one.
For the last one, it says x greater than or equal to 2. So you certainly have to start at 2. Sorry, these are both open circles, by the way. You certainly have to start at 2, but the question is, well, where should you go? Sometimes you just increment by 1.
Okay.
So give me those 3 points, please.
Um, so -4. Or, yeah.
Okay.
Uh, -5. And then probably -6. But,
Recommend trying the number.
yep, -6. Not good to guess.
4 minus 3 is 1. 1 squared is 1. 1 minus 5 is -4.
Wait, hold on. Does that say x equals 2 for the, or x is greater than?
Greater than or equal to 2.
Okay. So so if there's no other numbers, you just were like assumed
Just,
that you can just
yeah,
go up.
just keep going. Yeah.
Okay.
All right. So If you had graph paper, I would recommend trying to graph this. I'll help here. So -6, -6, 1, 2, 3, 4. So only will go out 8. No, it goes out 9. All right, and then -1, -4. Now, what type of function is this first piece?
All right, we talked about it. So the square root.
Yeah, so it's not a straight line. It's got to have like some curvature to it,
Okay.
something like that. Okay, the middle piece here is -1, 5. 1, 2, 3, 4, 5. And then 2, -7. 1, 2, 3, 4, 5, 6, 7. What kind of graph is the third one?
Um. Uh. I don't know. I'm gonna say like exponential or linear or something.
Yeah. Now, if you were a basketball coach, came to you and said like, what kind of defense are they playing? And you said 2-3, 3-2, box and one. What would be the punishment?
They're gonna punch me in the face.
Yeah. Right. It's bad. It's bad. You should kind of have an idea of what's happening here. And I know it's math. It's easier when you could see if it's man on man or, you know,
Yeah.
two guards, three, whatever. Like it's easier to do that. But it's the same principle. So this
Okay.
square, x squared means it's quadratic, it's U-shaped. This isn't rocket science. This is just some basic understanding of what functions look like.
Okay.
Okay, so we're going to graph these points 2, -4, 3, -5, 4, -4. Now, I really want you to graph a few more here because we don't have a good sense of what's happening. So I'd like you to put 5 and 6 into this here, please.
Okay. Can you go back to the x squared example, or just like for the like the definitions of the?
Yeah, we'll do that. We'll do that after
Okay.
this. I'll grab a snip of that for you. But
Okay.
just could you give me the two other outputs here?
Yes. Um. Wait. Why do we need more outputs
Well,
for especially for this one?
what happens after you hit this point on the right? What happens after this point? Do you know?
Oh. Okay. Okay. I get it.
Maybe you know, but like let's just do a couple more points just to be sure.
Okay. All right. Yeah. Okay.
You can
Um.
see it now on the screen.
Yeah. Yeah. So -1
Okay.
and 4. Did I do that right? Hold on.
Yep. Good. So
Okay.
5, -1 here, 6, 4, 1, 2, 3, 4. So we've got a better sense now of what's happening.
Yeah.
Okay. Now be as, direct as you can be. What about this do you feel like you couldn't do at this? You could not do at this point?
Like like what? Like personally, like what could I
Yeah,
not
like
do?
anything we just did. I mean, I wrote it all down, I graphed it, but like what do you feel like you could not do at this point?
I feel like, well, for me, I feel like I can do this. It's just, it's weird. My professor just, I think, just makes it more complicated than it should be. Like, we don't do, I don't know if we really do that many, like, T tables or tables. I mean,
Yeah. And that's the only way to do this. This is the right way to do it.
Okay. I'm not
Sometimes
like that.
people make things complicated if they don't really understand it.
Yeah.
Okay. So this word was on your worksheet there, discontinuity. Any idea what that means?
Discontinuity. Oh, I definitely have heard this word. Oh, it's probably because we did it in class. Hmm. I don't know. I don't know.
So in words, it's a break in the graph. So imagine you're over here at this open circle, you're going to the right, you hit this other open circle. How do you get up to this line here? Well, there's a break. This is more specifically called a jump, but do you agree that there's a break in the graph here?
Yes.
Okay, so and the discontinuities are x values. So it's discontinuous at -1, and then you're back on the graph, you're going down here, you're fine, you're fine, you're fine. And then what happens from this open circle to this closed circle?
There's another break.
There's another break. So it's also discontinuous at 2. So the other way that students it's told to students is drawing it without lifting up your pencil. So if you have to lift your pencil up, you're drawing this, lift it up, drawing this, lift it up, that's discontinuous.
Okay. But so on the paper it also says like their type, and what does that? What do they mean? What does it mean by that?
Let me go look. Okay, yeah. All right. Let me yeah, let me give you the types here. So the first type is called a jump. This is called a jump when you're you've got some sort of a gap.
Okay.
Okay. That's the first type of discontinuity. The next type is called a vertical asymptote. Have you seen those before?
Yes.
So that's where they're disjointed completely. Like you're going up forever, you're going down forever. And another example here, they could be going in the same direction, like it could be both going down, but there's no way they don't touch. Um, they don't connect together. The third type of discontinuity is a hole, and that's where there's a lot of possibilities here, but this is this one is considered removable because you can fill in a hole.
So the like the discontinuity is just the circle.
There's three types of discontinuities. There's a jump. Don't focus so much on the hole filled in or not filled in. It's
Okay.
it's the it's this gap that's called a jump. It's a vertical asymptote or one where the graph's moving away from each other
Okay.
or they're moving towards each other. There's just no way for them to connect. The hole is fillable here. Um, but it could look a lot of ways. I mean, it could look like this. That would also be a discontinuity, but there are three types.
Okay.
This
But
is
how is
something you see in, oh, sorry, go
hold on.
ahead.
How is this how is the third one? The third one's throwing me off a little bit. How's the third one a discontinuity if there's no like space in between them? Like on our
Y-
graph that we made, just because there was a open circle doesn't mean that that was a discontinuity.
Yeah, You're asking really good questions that can be answered with calculus, but not with algebra 2, which means the more information I give you, the more confusing it could be um, in this topic. If you go back to the more basic definition, like can you draw this without lifting up your pencil? You do have to lift up your pencil. You have to go from that place to that place. Like you can't just draw it straight through.
Okay. Can we? Okay. Can we talk more about like continuous or discontinuous? That also is a little weird. And
All right.
he used that in his explanation for uh, the discontinuity question. He was
All
talking
right. So
about
this graph is continuous that I just made here. Although there now it's gone. Ah, blessed. Okay, there we go. All right. This is considered continuous. It has no breaks, no jumps, no asymptotes, no hole. You can draw it without lifting up your pencil.
okay.
This one is also continuous.
Okay.
So you might be wondering, well, what does discontinuous look like? Well, we've covered the three examples. Let's see if I can find a worksheet here with some problems on it. Um, is this one continuous? Meaning, can you draw it without lifting up your pencil?
No.
It is not. There's an issue here. And this is considered a vertical asymptote. So you would say discontinuous at x equals -1, and you would call it a vertical asymptote. Here's
Okay.
another graph to look at. Is this one continuous?
Um. No.
Why not?
Well, you still have to pick up your pencil for it, right?
That's right. That's exactly right. So this one is discontinuous. What is the x value where it's discontinuous?
Two.
2. And do you remember the name for that one?
Um. No. No, I don't.
The jump.
Oh, okay.
All right, here's another one for you to look at. Oh, this one is always this worksheet has the same ones. Okay. Yeah, so continuous or not.
No.
Discontinuous at x equals 2. What kind of discontinuity is that there?
It's not the jump. Uh, what is the third one again?
All right. Are you going to take some notes today?
Yes.
Okay. That would have been a good one to get down. The three
Yes.
discontinuities: hole, vertical asymptote, and jump. And I
Okay.
know I
What is
send these to you at the end. Um,
hole? Okay. Well, I don't know. I don't know if any of these like fit that description of just a dot. Uh,
this is the hole right here, the open circle.
okay. So it's the whole. It's the third one then.
Yeah, it's this one is a whole, yes. Any questions on that?
I don't think so. The hole's a little weird, but I think the other
Yeah,
two are.
it's literally a whole, like, I know it's filled in there, but it has to be filled in where it's coming together.
Okay.
Okay, do you want to talk about middle behavior or do a little bit more on this continuity stuff?
Maybe give middle behavior a try.
Okay. Okay, let's look at another graph here. All right, so this graph has one breakpoint where this red line is.
Okay.
And there's this notation that is out of scope for your course, but actually you're not using limits. Let me not do that. Sorry, you're not in calculus. Okay. As x approaches 2 from the left. So your teacher probably said this means from the left.
Yeah.
Okay, so from the left, does that mean you're starting at A or B if you're coming from the left to 2?
A.
A. Yeah, you're coming from the left. You're traversing the curve from the left. What is the Y value there? That does not exist, but assume it exists. What is the Y value there?
Hold on. Let me write that. Okay. 3.
It's 3. And then we go the other direction as X approaches 2 from the right. So now we're coming from B. What does it approach? What does f of X approach? What's the Y
1.
value? 1. So that is the middle behavior.
Okay.
All right, so let's try another one here. Okay, let's focus on this right here, that's red. That's X equals 1. As X approaches 1 from the left, as X approaches 1 from the right, what does this become?
Um. Let's see. 0 from the left, and then 1 from the right.
Okay, very good. Now, how about, now we're going to do it at 2. X approaches 2 from the left as X approaches 2 from the right. What does f of X approach?
Um. It's kind of weird.
So ignore this dot. This dot is irrelevant. What is it approaching from the left, from the right? From the
It's
left, from the right. Yeah, what is it approaching?
1 for both then.
Yeah, very good. Okay, thoughts on that?
Okay. I mean, that doesn't
Let me
seem too hard.
let me give you another one here, a little more complicated. Okay. As x approaches 0 from the left, what does f of x equal?
Um, -4.
That is correct. How about as you approach 0 from the right?
-7.
That is correct. All right. How about as x approaches 7 from the left? As x approaches 7 from the right?
This is kind of weird now. I mean, are we gonna use the little line in this part?
So you're coming, so from the left, like you first figure out where is 7, okay? And I'm just going to show it here in red. There's 7 from the left, from the right.
Okay, I don't know why I thought we would be using the far left equation. That wouldn't make sense.
Yeah, you're
Okay,
approaching 7. So
okay,
wherever
from the
7 is
left,
on the graph.
-6.
Okay.
And on the
And
right
from the
is
right.
-2.
Good. Okay. So where this gets more difficult is if I don't tell you, I don't like start you out here um with that, but maybe maybe that's clear. Let me go find another graph or two for us to do this with. Um,
Okay,
all right, here is one. All right, so this time I won't give you the x value. You have to decide what the x value is. Like, where is the middle behavior?
okay. Um, like where it approaches.
Yeah, like in the previous problems, I always gave you like as x approaches, as x approaches. You have to decide that here. There's only one place though,
I'm gonna
maybe.
assume it's the in between the 2 points that are connected.
Okay, what's the x value that you're thinking of?
Um, 4.
You're talking about down here.
Yes.
So maybe not wrong. This middle behavior is nonsense that only your school does. It's really not reasonable to do. Yeah, you could do that. You could do as x approaches 4 from the left and 4 from the right. I was hoping you would either pick 8 or -2 as the other places,
Okay.
but it's very unclear, truly. Like it's not as cut and black and white as it maybe could be.
All right. So, I guess if we're doing that, uh, mm, shoot. Uh, this is weird because there's 2 points on the left side of it.
Well, again, it's what is it approaching? What is it approaching?
4,
Well, x
4.
is approaching 4, but what's the y value?
Well, there is no like y on 4. Oh wait, what am I talking about? Sorry. Let me zoom in. 4, -3, right?
Yes, approaches -3. All right, can you tell me as x approaches 8 from the left and 8 from the right, what does it become?
Yeah, 8 from. Okay. That would be 3 for on the right.
I don't think so. Try again.
I'm sorry, I'm having a hard time thinking straight right now.
Do you need a short break? I mean, I heard you maybe munching on some food. You need just to quickly.
No, no, I'm all right. I'm all right.
Okay.
Already, it's already falling out of my brain here. Uh, is it -3?
So 8 is over here in blue. From the left, from the right.
Oh, okay. I was okay. Okay.
Like when your coach says force him left and you're playing defense, which way are you forcing him?
Hopefully left.
His left, your right.
Okay, I think I got it. Is it for from the right? Is it 6?
Okay.
And then from the left, 6, -6.
I mean, from the left, I'm just looking at the y value. I mean, it looks like it's about 3. The y value right there.
I wasn't sure if it was the open or the closed dot that we were supposed to be looking at for the
But
left.
where it's 8, it's 8. It's as if we're coming at it from the right, from the left.
Okay.
It's like you go until there's nothing else there. It's like I got to the end. What's there? Well, what's there is +6. From the right, what's there is 3. Okay,
Okay.
I'm gonna give you a couple more here. Do you just need a minute or two break? Are you good?
Yeah, maybe just a quick minute and I'll be all right.
Okay, yeah. Check back with me in 6:39. Okay.
Okay.
Okay. Ready to do a couple more problems here before we close out?
Yeah, I'm ready.
All right. I know this isn't exciting. It's weird that you even have to do this, but uh, this is what you've got in front of you.
All
Okay.
right.
To me, there are two places where there's middle behavior. Can you give me those X values where you believe that there could be middle behavior?
Yeah, I'm thinking -3,
Agreed. They're at -3. And then what's the other one?
2.
X equals 2. Okay. Let's focus on, let's do the 2 first. As x approaches 2 from the left, x approaches 2 from the right. This will be so much easier when you have it in front of you because you can actually draw it from the left, from the right. What is the y value that those are approaching in each
Well,
case?
um, from the right is 3.
We're talking about this point right here.
Yeah.
The y value is not 3.
Wow.
3 is up here.
Okay, I don't know what I was thinking.
Well, you're tired. I mean, 3 is between 2 and 4. It's -3.
Okay. Okay.
Can hear it. How about 2 from the left? From the left.
So it's from the top. Uh, is it from the top or is it from the point on the left there?
So the blue arrow, I'm trying to show you what from the left means. It's like I'm trying to get to 2. Got to come at it from the left. It is from the top, but it's the left is the better word. What's the y
Mm,
value there?
is it 4 then?
The y value here.
Oh, then it would be just 0.
Yes. Okay. Now, as x approaches -3 from the left, x approaches -3 from the right. So from the left, that's that first green arrow. From the right, that's that second green arrow.
Okay. Um.
And always the y value. The second number is always, always, always the y value.
Okay, so from the left is just 1.
Which one is it? You said from the left. Yeah, it is 1.
Then from the right is -5.
It is -5. Good. Okay. I've got one more graph here. There is, I want you to write out any middle behaviors that you see.
Okay. I see one at 3.
Yeah, let's just go with the one at 3.
Yeah. Okay. Sorry. So let's see. So from the left, I think it would be 7.
You want to say it this way, as x approaches 3 from the left, f of x is 7. Okay,
Okay,
so can you
so
give me it from the other direction?
as x approaches 3 from the right, f of x equals 4.
Good. All right. Any questions on that?
Nope. All good.
All right. Let's do one more. Okay. Give this one a try, please.
All right. So there's 2 at -2 and at 3.
I would agree.
Um, so Oh yeah, so from oh yeah, as x approaches -2 from the left, f of x equals um 3.
I agreed.
And then as x wait, how do we say it from the beginning again? X
X approaches -2 from the right.
approaches, okay. That would be 5.
Okay.
F of x equals 5. Um and then okay. As x approaches 3 from the left, f of x equals I think this is 5.
It was 5. Good.
And then as x approaches 3 from the right, f of x equals um 3.
What number did you say?
3.
Yes. Good. All right. Any questions that you have on middle behavior?
Nah, I think I'm getting it.
Okay, I would agree. On these piecewise graphs, I strongly recommend the table and labeling the points. You've got kind of those rules down. Very briefly, there are like 10 parent functions that you might need to know. And I don't expect you to know all of them, but it would be good to have like just a basic guideline of them. So let me grab this you had asked about earlier. Um, he also asked, well, how do I know them? Well, you just find a way to remember stuff. The lines are going to have x to the power of 1. The constant, those are horizontal lines. Talked about that. The quadratics are U-shaped. They're either up or down. You and I have not talked about cubics, but the root functions have kind of this thing. So,
Okay.
all right, why don't we just stop here for today? A little
All right.
early, sound pretty tired.
Yeah.